Welcome to Ask and Learn.
In this problem, we have an object that's being pulled to the left by some constant force F, and we know that right before it's pulled, its distance is 2 meters. And we know that because we're dealing with a force, and we're dealing with a distance, we know that this is the equation for work. Work is just force times distance S. And it's just this simple equation because the force is constant. And in this problem, we want to find the velocity, which we'll call v2, when the object reaches the end, or when its distance is 0. So since we're dealing with work and we want to find a velocity, we can use the work energy principle, which is just the initial kinetic energy plus the work being done is equal to the final kinetic energy. And of course, we can expand this to 1/2 mv1 squared, v1 for the initial velocity, plus the force times the distance s is equal to 1/2 mv2 squared, v2 being the final velocity, which is what we're looking for. And we know that when it's at 2 meters, the object is at rest, so the initial velocity is 0. So this part of the equation is 0 because v1 is 0. So now we can simply solve for v2. So to do that, you multiply both sides by 2 to get rid of the 1/2. Then you divide both sides by m to get rid of that m. And because v2 is squared, you take the square root of both sides. So we have v2 is equal to 2 f dot s divided by m, and of course, square root. Now we can just plug in our number. So 2 times f is given as 50 newtons, times the distance s, which is 2 meters, divided by the mass, which is given as 6, then take the square root. So the final answer is v2 is equal to 5.7 meters per second.